This video will cover the installation and operation of the digital application Fldigi on FM VHF UHF using a sound card interface. This offers the possibility of exchanging digital messages locally during an emergency using either simplex or repeater operation. In an emergency where internet services are unavailable, Fldigi can offer an alternative to VHF and UHF peer-to-peer WinLink for local emergency digital communications using a relatively low-cost sound card interface between a VHF-UHF FM transceiver and a computer. One sound card interface that's easy to install and use with Windows computers is the Tigertronics Signal Link unit that currently costs $85, and connecting cables between the Signal Link and specific radios can be purchased for about $15. Of course, it's possible to make your own cable and save the cable cost. The Signal Link unit has a built-in Vox circuit that keys the radio's push-to-talk circuit. Simpler sound card interfaces may require other circuitry to automatically key the transceiver, so keep this in mind when you choose an interface. It may be necessary to connect the sound card interface to the transceiver's microphone input. Some transceivers feature a data auxiliary connector, usually on the rear panel, which is ideal because use of this connector enables one to switch between voice and digital modes quickly. Switching back and forth quickly can be a very helpful thing to do by first using voice to establish a connection on an FM VHF UHF frequency and confirm the digital settings before actually initiating the digital transfer. Examples of radios with data connectors are the single-band Alinco DR135 and DR435, the dual-band Yaesu FT8800R, the Kenwood TM-V71A, and the ICOM 2820H. There's also a simple modification to the older 2-meter Kenwood TM-271 radios to create a separate digital connection. Finally, there are a number of HF radios that also cover the 2-meter and 70-centimeter bands with separate auxiliary connectors, such as the Kenwood TS2000, the Yaesu 857D and 897D, the ICOM 7100, and the ICOM 9100. Obviously, these HF radios will also provide the capability of using Fldigi on the HF bands in addition to the VHF and UHF bands. Before jumping into Fldigi, let's talk just a little more about the ways to exchange digital messages locally during an emergency. The WinLink system offers several ways to exchange digital data and messages over amateur radio. However, perhaps the most useful capability provided by WinLink is to get messages in and out of the local area using radio links to areas not affected by the local emergency. If local internet services are rendered inoperative by the emergency, local digital message exchange would probably be limited to the store and forward capabilities of surviving local packet VHF-UHF gateways running RMS relay software, digipeaters, or packet networks. The other possibility is peer-to-peer packet connections between specific VHF-UHF stations. Peer-to-peer HF connections locally with NVIS antennas are also possible using Pactor or the Winmore sound card protocol. Although Winmore is possible with VHF-UHF FM, it is not common or customarily used in this way and is designed primarily for HF radio links. As an alternative, or in addition to the WinLink system, there are a number of other digital sound card modes available to the amateur radio community. Many of these work well with our FM VHF-UHF radios, both in simplex and repeater operation. Several application programs are available which implement sound card modes, and Fldigi is one of these. It offers several attractive features, including the fact that it is available free of charge for Windows, Linux, and Mac operating systems. It is capable of a large collection of sound card modes such as PSK, MFSK, MT63, and Olivia. In addition, it includes several ancillary programs such as FLMessage, FLWrap, and FLAMP, which provide a long list of useful message formats and templates, and checksum methods to indicate accurate message transmission. Broadcast messages are possible, which facilitates digital net operations, and message reception with unattended stations is possible. Of course, Fldigi can be used with HF as well, and is already promoted by a number of ARES groups, such as the West Pennsylvania ARRL section, and Yahoo groups such as PA NBEMS and NBEMS Ham. There are HF digital nets in a number of states, including New York, Pennsylvania, Michigan, Virginia, Arkansas, Minnesota, Idaho, and California. They typically use Olivia and MT63. Okay, now let's turn our attention to Fldigi. Go to the website www.w1hkj.com/download.html. You'll see the following list of programs available to download. Since I'll be using Windows, I'll select the following applications: Fldigi, which includes FLARQ. Next, FLAMP. Then FLWrap. And last, FLMessage. Save these files where you can locate them and install each one. The installation software will put a shortcut icon on your desktop. Note there are help files you can download for more information about the applications. You may want to download and install additional applications after you're familiar with Fldigi, and you may want to explore rig control if you're using a radio with HF capability. Open the Fldigi application and let's enter some setup information. Click on the Configure menu, then select Operator at the top, and a second window will open. Enter your call sign, name, and other information for your QTH. Don't forget to click on the Save button, then go ahead and close the window. Go back to the Configure menu and this time select the Miscellaneous category. The Configuration window opens and select the NBEMS tab. NBEMS stands for Narrowband Emergency Messaging System and refers to the suite of Fldigi software. Make sure all these boxes are checked. In this window labeled FLMessage, enter the path to the FLMessage application in your computer. If you click on the Locate FLMessage button, you can use the normal navigation tools in Windows to find the FLMessage application. This step allows Fldigi to automatically open FLMessage when a properly tagged message is received. Click the Save button. Next, click on the Modems tab and then click the MT63 tab. Make sure that all the boxes are checked and click again on the Save button. Go ahead and close the window. To see all the digital modes Fldigi supports, click on the Op Mode menu. Select the MT63 item, and in the submenu select MT63-2KL. This selection is confirmed in the lower left-hand corner of the window. MT63-2KL is the recommended digital mode for VHF-UHF FLMessage messages. Now let's again click on the Configure menu and select the Auto Start item. In this window, you can select a number of applications that will be opened when you start Fldigi. Here I have chosen to open FLAMP, FLMessage, and FLARQ. If you click on the Locate buttons, you can use the navigation tools in Windows to find the application files. Don't forget to save your changes. Note that unlike FLMessage, Fldigi does not automatically open FLAMP if a broadcast message using this application is received. FLAMP must be open when the message is received. Now let's set up a few things in FL Message. Click on the Config menu and select Personal Data. Enter the information about you and your station. Now select the Socket tab. Don't change any of the information at the top, but make sure the Sync Modem to Fldigi box is checked. This makes sure the FL Message application and the FLDigi application are always using the same digital modem and can prevent some confusion later on. You can now close the config window. No save required this time. Now we're going to select the computer sound card that FLDigi will use. Go to the Configure menu again and select Sound Card. Select the Devices tab. Make sure the Port Audio box is checked. The Capture and Playback pull-down boxes will show the available sound cards on your computer. For the signal link, select the ones that are indicated by the USB audio codec. Save your selection and close the window. Now the next step is not required, but is recommended. The sampling frequency on some sound cards is not precise, so we will measure how much our sound card deviates from normal. We will use a utility program called checksr.exe, available at the link shown on the screen. I have downloaded checksr and placed a shortcut on my desktop. Open checksr and select the sound card for the input and output. Click the Start button. The numbers at the bottom begin to change. These numbers will begin to stabilize over time. Let checksr run for about 15 to 20 minutes. After the numbers stabilize, then click Stop and write down the resulting numbers for the input and output in parts per million. Now we'll go back to FLDigi and enter this calibration data. Click on the Configure menu and again select Sound Card. This time, choose the Settings tab and enter the parts per million figures for the receive and transmit calibration. Save and close the window. Okay, let's go ahead and send an ARRL radiogram using FL Message. If the radiogram were not showing in the window, we would have to first select it by going to the Form menu. First, we'll choose the message handling instructions by clicking on the HX pull-down menu. Next, we'll select HXG and transfer this to the HX text window. Click OK. We'll proceed now to fill out the rest of the message blocks. When we're done, we'll click the Auto Send button at the top of the window. FLDigi now automatically sends the message. Now let's watch an ARRL radiogram being received. The message is saved in an MBES file directory, is displayed in another FL Message window, and finally is displayed as a fully formatted radiogram in a browser window. The formatted radiogram can be printed from the browser. Now let's send an ICS 213 form. In FL Message, go to the Form menu. Select the ICS category and finally select the ICS 213 form. Go ahead and fill in the various boxes in the form. Notice that FL Message is showing you the message size and transmission time in the lower right-hand portion of the window. When you're finished, click on the Auto Send button and Fldigi prompts you to save the message and then automatically starts transmitting the message. Now let's watch the reception of an ICS 213 form. When the reception is complete, Fldigi opens the directory where the message is stored, another FL message window, and finally opens a fully formatted ICS 213 in a browser. Notice that there is a reply in this ICS 213. This reply can also be viewed in FL Message by clicking on the Responder tab. Let's take a look at a connection with FLARQ. ARQ stands for Automatic Repeat Request. Data is sent in blocks, and if the receiving station detects an error, it automatically requests a retransmission from the sending station. For the ARQ protocol to work, both stations must be running FLARQ. The Fldigi help files state that MT63 is compatible with FLARQ if the program timing is increased to accommodate MT63's latency. However, I have not had success using MT63 with FLARQ, so I will shift to the PSK500R digital mode for this test. The R signifies that this is a robust version of PSK that uses both forward error correction and interleaving schemes to improve signal-to-noise compared to the standard PSK. First, let's look at the configuration information. Click on the Config menu, enter your call sign and a short beacon text. The beacon text will be sent during the ARQ connect process. I have entered beacon DEW4BGH. Don't change the other information, then click OK. In this case, the station K4PPK will send a beacon. After the beacon is received, the call sign K4PPK appears in the space at the top of the window. Now click on the Connect button, and the connect process proceeds between the two stations. The two operators can now conduct a keyboard-to-keyboard conversation in the plain talk area at the bottom of the window. K4PPK now proceeds to send a text message. Either station can now initiate a disconnect. I can now recover a copy of the text file. Click on the File menu in Fldigi. Select Folders, and in the submenu select NBEMS files. Open the ARQ directory, and then open the directory called RECV for receive. We see the file called tommy.txt, and double-clicking on this file reveals the text message sent by K4PPK. Let's turn our attention to the FLWrap utility. The purpose of this little application is to wrap a text or other type of file into another file which has a checksum embedded in it that will tell the receiver whether or not the file was received without error. There is some compression capability, but doesn't make much, if any, improvement with small text files. In general, be careful with large files because even with some compression, they could be so large that the transmission times could easily exceed repeater timeouts. Operation of FLWrap is fairly simple and straightforward. When you open the application, a small window appears. There is no setup to worry about. To wrap a file, just drag it into the drop area on the right-hand side. FLWrap always creates the wrapped file in the same directory as the original file. I have a file on my desktop called tommy.txt, so I'll drag it into the drop file here box. Notice that a new file appears on the desktop named tommy.txt.wrap. Note the original file and the wrapped file are almost the same size. To send the wrapped file, just drag it into Fldigi's transmit pane, which is the blue area in the Fldigi window. Then hit the TX macro key in the lower right. Here is a wrapped file being received. You'll see an indication at the bottom of your Fldigi screen that a file is being extracted. Watch the incoming data for the wrap:"end" designator. The folder that contains incoming wrap files opens, and look for the most recent extract file. Drag and drop it in the FLWrap window. If the checksum was verified, the original file that was transmitted will appear in the RECV directory. When we open this file, we see the original text. Let's move on to FLAMP. AMP stands for Amateur Multicast Protocol. This will transmit one or more files with one or more iterations of the transmission. The file is broken into blocks, each with a checksum. If the receiving station misses some blocks, it can report the missing blocks and the transmitting station then resends them. Let's look at the FLAMP setup. Click on the Configure tab. In addition to your station information, check the Auto Sync FLAMP to Fldigi box. This makes sure both FLAMP and Fldigi are using the same digital mode. Next, check the Enable TX on Report box. This enables Fldigi to transmit a list of the missing blocks with a single click on the Report button in the Receive tab. If you're using a repeater, you will want to check the Enable TX-RX interval box and set the appropriate durations so you will limit the transmission time and not time the repeater out. Let's go ahead and transmit a file using FLAMP. Make sure the Transmit tab is selected at the top. The Send To line defaults to QST for a broadcast message. Click Add or drag the file into the DND icon in the middle of the window. The file name is added to the transmit queue. More than one file can be added to the queue at this time. Type in a brief description. You can now select the block size, the number of times the message will be sent, and the number of times the headers will be repeated. The file size and the transmit time is shown. Now click on the transmit key. After a brief pause, the receiving station sends a message. We click on the Fetch key that tells us they have missed block 1. We now click on the Transmit key again, and the missing block is retransmitted. Here is a file being received using FLAMP. The Receive tab has been selected. We can see the file name is placed in the Receive queue and other information is entered in the boxes above. During the transmission, I will move the receive center frequency in the waterfall to generate some errors and missing blocks. You can see that blocks 4, 5, and 6 are missing. I'll click in the Report key and Fldigi sends the missing block numbers to the originating station. Now K4PPK retransmits those blocks which are correctly received and the message is regenerated. I click on the Save button and the file is saved. The file can be recovered by opening FLAMP's File menu, selecting Folders, which opens a directory. Open the RX directory and open the most recent file showing the message just received. Let's review some of the information about Fldigi. It's a free set of digital sound card applications that run on Windows, Linux, and Mac operating systems. It supports a large number of digital modes, some with enhanced capabilities over their standard counterparts. Some of the Fldigi applications provide error reduction or correction through checksums, error corrections, or the retransmission of data. FLMessage incorporates a large number of useful message formats that can be printed in fully formatted forms. Sound card digital modes can be used in the amateur radio high-frequency bands, normally with the upper sideband, but they are also usable with FM radios in the VHF-UHF bands. This capability makes the Fldigi NBEMS suite of applications interesting for locally transmitting digital messages in emergency situations, especially when the internet service is unavailable. Furthermore, both simplex and repeater operations are possible. If our FM radios can be configured for rapid switching between voice and digital modes, net operation using both modes is feasible. I believe this makes our digital transfer more reliable by being able to coordinate operations on multiple frequencies and by confirming digital configurations by voice prior to attempting the actual data exchange. The capability to use both voice and digital modes also means a single FM radio can be used for multiple purposes in an emergency. The West Pennsylvania ARRL section has published a set of standards for digital MCOM. Here are a few of their recommendations. County emergency coordinators should designate one repeater and one simplex frequency as digital VHF-UHF channels. MT63-2KL should be the standard mode for simplex or repeater channels. FL message should be used when passing traffic using a standard formal format. FLWrap should be used when absolutely no error is acceptable. Transmission of binary files, such as Word documents or Excel spreadsheets, should be discouraged because of their large file sizes. One additional caution when using repeaters with sound card modes. Make sure that the lower edge of the waveform on the waterfall is above the PL decode range. A safe number is 500 Hz. It may be a good practice to keep all digital modes centered at 1500 Hz. An incident or disaster is no time for experimenting, so I encourage everyone to experiment with these sound card modes and Fldigi on your FM radios before they might be needed.